Okay, question number 14. Find the absolute maximum and minimum over indicated interval. All right, so what do we have? 6x minus 7. Oh, this is too thin. Let me make it thicker. There we go. And it's gonna be on interval -3 and 6. It's square brackets, right? Because square bracket means numbers included, yes. So if it's parentheses, that means these end points are not included. Square bracket meaning -3 and 6 are included. So how do we, first of all, absolute, till now we dealt with relative minimum, maximum, or extrema, or local extremes. So absolute one. Let's say we have like this. So this is maximum, right? Maximum, max, max, max. Those are all relative maximum. This is absolute one, because the highest one. And this is absolute minimum, because it's the lowest one. And those local minimums. Okay? Just so you know. All right. So we need to find absolute maximum, absolute minimum on interval -3 and 6. So for that, first thing we need to find first derivative. Remember, finding first derivative, assigning 0 to 0. F prime of x is equal 6x. To assign to 0, we are getting 6x is equal 0. Oh, duh. Sorry. Derivative of 6x is 6. Which means, if I assign it to 0, then I'm getting 6 is equal 0, which is nonsense. If anybody can prove that 6 equals 0, will be next Nobel Prize winner. Okay, so that means what? On interval -3 and 6, it's the derivative is going to be constant and never 0. That means on interval we don't have any maximum, we don't have any minimum. So what we have left, since this -3 and +6 are also included, sorry, imagine it's a straight line. Then we need to test find the -3 and 6. That means these endpoints are going to be our critical point. It's going to be either absolute max or absolute minimum. So let's figure it out. One of them going to be absolute maximum, one of them going to be absolute minimum. So I am plugging -3 first, f of -3. Pay attention, I'm not plugging into derivative, I'm plugging into original problem, because we already assigned derivative to 0 and we got constant there. So f of 3 is going to be equal 6 times 3, oh, -3, 6 times -3 and -7. So we are getting -18 and -7 is going to be -25. So we have -3, -25. So we know this is at the critical point, but max or minimum we don't know yet. Now we are taking f of 6. Let me take thicker one. So f of 6 is equal 6 times 6 minus 7. And we are getting 36 minus 7, it's going to be 29. So points are going to be 6 and 29. Let me put this also, oops, make it thicker also. Oh, this one. Okay, let it stay with color. So we have negative 3, negative 25, and positive 6, positive 29. Let's see. Negative 3, negative 25. This is this point. And positive 6 and positive 29. Let's say it's somewhere even higher. Yeah? 29. 29, and this would be 629. And this one will be negative 3, negative 25. Well, obviously, negative 3, negative 25 is going to be minimum. And 6 and 29 going to be maximum. And indeed, if we provide the graph, it's going to go, our original problem is 6x minus 7, right? So it's going to be, okay, like this. And it will cross in the point negative 7, right? Okay, so let's place the answer. 6 and 29 is our max. So 29 at the point of 6. Fantastic. And the other one we have negative 3, negative 25. So since it's asking why negative 25, because asking minimum value, absolute minimum value is negative 25, and this is going to be negative 3. Okay, moving to next question. What do we have? Question number 15. Okay. So let's write down x squared minus 2x minus 1. And it's going to be on interval negative 2, negative 5. Let me double check, because usually I can put a wrong interval. Positive 5, see? Okay. So what we need to do, find, first thing we have to do, find the find derivative, right? So f prime is equal to x minus 2, right? Okay, to find critical value, because we need to find either absolute maximum or absolute minimum. So it doesn't matter absolute or local. So to find maximum minimum, we need to get first derivative and assign it to 0 to find x. Now we assign to 0. Which means 2x minus 2 is equal 0 and x is equal 1. Okay, so we have three options that can be, are critical, the three critical points, and we need to find out which one of them is maximum, which one of them is minimum. Which are our critical points? It's 1, it's negative 2, and 5. Okay, it's not going to be within interval, because we have standard 1. X is equal 1. And we have to go now through every single point. Okay. So I'm going through original one, plugging 1, negative 2, and 5 into original problem function, f of 1 is equal. So 1 squared minus 2 times 1 minus 1. So 1 and 1 is gone, and we have negative 2. Okay? Next, f of negative 2 is equal negative 2 squared minus 2 times negative 2 and minus 1. What we are getting? 4 plus 4 minus 1. We are getting 7. So here coordinates are going to be 1 and negative 2. Here we have coordinate negative 2, positive 7. And lastly, we have to find the value of y for x is equal 5. We have 5 squared minus 2 times 5 and minus 1. We get 25 minus 10 minus 1. 25 minus 10 is 15. 15 minus 1 is 14. So coordinate here 5 and 14. So from here, which point is going to be lowest if I provide the point here on the graph? So 1 and negative 2. And then negative 2, positive 7. And third one, 5. Let's say this is 5. And positive 14. So looking at these positions of y's, we can say that this point 14 is going to be maximum, right? This one doesn't play any role. This one is going to be minimum. So this is going to be our minimum. So 5 and 14, let's put it. 14 here. 5 is here. That's absolute maximum. And minimum is going to be 1 and negative 2. So the value of y is negative 2. And this is negative 1. What? I think something I copied wrong. Oh, 1, positive 1 and negative 2, okay. There we go.